Alright, 8th graders, lesson 54, angle relationships here. We've got a couple of angles. We've numbered them 1, 2, 3, and 4. So let's talk about some of those there. We have some adjacent angles, and adjacent just means that they are next to each other. If you're adjacent to someone, it's the person you're sitting next to, or your house is adjacent to the neighbors. That's right next to you, not behind you, but adjacent means next to you. So there's quite a few adjacent angles in here: 1 and 2, 2 and 4, 4 and 3, 3 and 1. So down here we could say angle 1 and angle 2. Angle 2 and angle 4, angle 4 and angle 3, angle 3 and angle 1. So 4 total adjacent angles in here. And we also can talk about opposite angles. Angles that are opposite, also we call them vertical, although in this case it'd be a horizontal angle. But vertical angles, opposite angles, so opposite angles here would be angle 1 and angle 4, angle 2 and angle 3. So can do a better and symbol there. Those are called opposite or adjacent angles as well. We also want to take a look at the lines of angles and the degrees they make. If we look at that, we have this line here. We know a line makes, well, a line is 180 degrees. So if we can find out the measure of this angle here, we could learn the angle measure of 1, or if we knew the measure of angle 1, we could figure out the measure of angle 2. So if we go ahead and put that in there, we say this is 60 degrees over here. This will have to be 120 over here to equal 80. Because 1 is opposite of 4, this will also be 120, and you can look at it two ways now. With number 3 over here, we can say, well, we're adjacent with angle 2, so it'll be 60, or we want to use these two angles to make 180. So this one must be 60, and these two together, when they equal 180, they also have a special name, and that is supplementary angles. Supplementary angles equal 180 degrees. When we add the two angles together, they will equal 180 degrees. So in this case, we would say 1 is supplementary to 2. 3 is supplementary to 4, or we could say it this way: 1 is supplementary to 3, or 2 is supplementary to 4. So a few different options there. Alright, we need to determine the angles of 1, 2, 3, and 4 in this example here. And so we see a few things. We know that these two angles should be adjacent, so they should be equal to each other. So we're going to say that this is a 40 degree angle, and these two here should be supplementary. So if this is 40, this is going to be 180 minus 40, so that will have to be 140. Now a triangle equals 180 degrees, and it's all three interior angles. We know this is 90, and this is 40, so that's 130. 180 minus 130 will be 50, so angle 3 is a 50-degree angle. And then these two angles here have to be supplementary. They form a straight line. So again, 180 minus 150 will be 130. So we are able to discover these 4 other angles just by knowing this one angle down here, using the idea of adjacent angles and supplementary angles, that all the interior angles of a triangle equal 180 degrees, and supplementary angles once again. So that's example 1. Alright, we've learned today that supplementary angles equal 180. This is a 90-degree angle here we see because of the right angle symbol. And when two angles together equal 90 degrees, we call those complementary angles. So 45 degrees plus 45 degrees equals 90, so they would be complementary angles. So in this case here, get rid of this over here, and we divide this the line right there, and we said we've got a measure angle there, we got another angle there. This one might be 30 down here, and this might be, well, that would make that one 60, because both of those together have to equal 90 degrees to be complementary angles. So we'll be using that in the future as well. Alright, and a little bit more information here. Here we see that this top red line and this bottom red line are parallel, and this line here that cuts them in is called a transversal. So it goes through both of those parallel lines and divides them up into making some angles. And there's different names that we want to learn about. We've learned about these adjacent angles or opposite angle, or these are adjacent, 1 and 2, and opposite or vertical angles, 1 and 4, adjacent 1 and 2. So we see lots of adjacent angles here, and we see lots of vertical angles, 1 and 4, 2 and 3, 5 and 8, 6 and 7. But the question is now, how can we relate these angles to these angles down here? And there's a few mathematical terms that we can use here. The first ones will be corresponding angles, and an example of corresponding angles would be something like 3 and 7. So angle 3 and angle 7. They are in the exact same position, okay, in each of those areas. They're in the exact same position. So 2 and 6 would be corresponding angles, 4 and 8 would be corresponding angles, and 1 and 5 would be corresponding angles. 2 and 7 would not be corresponding angles, even though they might have the same angle measure. They are not. The next term that we want to talk about here are alternate interior angles. Alternate interior angles would be something like 4 and 5. They're in the interior because this portion here, they have to be one of these 4 angles. These would be exterior, they're on the outside. So these are the interior angles, and they're alternate because they're on opposite sides of the line, but they equal each other. So in this case, alternate angles would be angle 4 and angle 5. They both would have the same measure. We don't know what that measure is at this point, but we know that they would be the same, 4 and 5. And then finally we have alternate exterior angles. That would be like 1 and 8 or 2 and 7. They are on the exterior this time. They are alternate because they're on the opposite sides of the transversal. And in the case of 1 and 8, again, the angle measures are going to be the same. So angle 1 and angle 8. The other alternate exterior angles would be 7 and 2. So those are 3 more terms for us. Again, we know 1 and 2, they're adjacent. They equal 180 degrees, so they're supplementary angles. Here we've got some vertical or opposite angles. They would have the exact same angle measure. So in this case too, if we were to come up with an angle measure and say this angle over here is 60 degrees, then we know this is 120, this is 60, this is 120. 4 and 5 are alternate, so that means they're equal. So this guy will be 60, this will be 120. So just by knowing one of these angles, we can figure out the other 7 angles. And we'll go on to do that here in example 2. Alright, so we can get started here with this one. They tell us in example 2, in the figure, parallel lines P and Q are cut by the transversal T. The measure of angle 8 is 55 degrees. What are the measures of angles 1 through 7? Opposite of 5 or 8 would be 5, so that would be 55. 5 and 4 are alternate interior angles, and 4 is opposite of 1. That's 55. 7 and 8 here are going to be supplementary, equaling 180. So 180 minus 50 is 130, minus 5 more will be 125. So then 6 and 7, they are opposite. 6 is an alternate interior angle with 3. And 2 is an alternate exterior angle with 7. So we can see all the angles equal either 55 or 125. Alright, let's look at example 3 here, talking about structural engineers. Triangles have been found in bridges to be extremely strong. So we want to find the measures of angles A, B, F, F, B, C, and F, G, B. FGB. Alright, FGB I think should be a pretty straightforward one for us here. That should be a 90-degree angle. So angle FGB equals 90 degrees. Alright, now this angle here we can determine a couple of different ways, but probably the most accurate way here would be to determine the total triangle. We have got 90 plus 40, 130, so that means this angle up here will be 50, and we know that this angle right here is a 90-degree angle. So 90 plus 50 is 140. So angle FBC equals 140. This is 50, and this will be 90 over here. So when we make this angle right here, we combine these two. And that leaves us with one other angle, angle ABF. Well, if we know this whole angle here is 140 degrees, it will be supplementary to this one over here. 180 minus 140 will equal 40. So it will be 40 degrees. You also could have said these are alternate. This angle and this angle here were alternate interior angles. Since we knew this one was 40, this would also be 40. So that's it for today's lesson. You can begin on your work.